children, hope you all are fine. Today we will be dealing with factors on which resistance depends on. So let us list it. The first factor on which resistance depends on is the length of the wire, or we can say that the resistance of a material is directly proportional to the length of the material, or if a wire is taken, it depends upon the length of the wire. It's directly related. R is proportional to L. The second factor on which resistance depends on is the area of cross section. So we have already discussed what do you mean by area of cross section. So once again we will take a recap. The area of cross section means if this is a cylindrical wire, the circular region shown here is what is meant by the area of cross section. So resistance is inversely proportional to area of cross section. The third factor on which resistance depends on is the nature of the material. You know that there are different types of materials like semiconductors, conductors, insulators, etc. So insulators offer more resistance to current. Conductor offer least resistance to current. So it may be due to the structure of different material. That is, they depend upon, the resistance depend upon the nature of the materials. And higher theories have proved that resistance of a metallic wire increases with the temperature. For semiconductors, resistance decreases with the temperature. So what are the factors on which resistance depends upon? To conclude with, it is temperature. So particularly for a metallic wire, you have to know that resistance is directly proportional to temperature. When temperature increases, resistance increases. To sum up, so what are the factors on which resistance depends on? Resistance is directly proportional to the length of the wire. Resistance is inversely related to the area of cross section. Resistance depends on the nature of the material, and resistance depends on temperature. Hope that you have noted this point. So let us just convert this thing to a mathematical equation for getting a suitable equation for resistance. So we have written that resistance is directly proportional to length of the conductor. Resistance is inversely proportional to the area of cross section. Resistance is proportional to the nature of the material. So for that, we are going to club these two equations where we get it as R is equal to, we are going to introduce a constant here. This is a Greek letter called rho, R-H-O. And combining this equation, we will get L divided by A. So this rho is called the constant of proportionality here. It is called the resistivity of the material of the wire. What is rho called? It is the resistivity of the material of the wire, or it is otherwise called specific resistance. Specific resistance of the material of the wire. So what is the constant of proportionality called? Resistivity or specific resistance. So we will get the equation for resistance as R is equal to rho into L by A. So while we do this numerical, what we have to do is that for area, it is area of cross section. For cylindrical wires, the area of cross section is pi r square. You know, for a cylindrical wire, when the radius or diameter of the wire is given, in order to calculate A, we have to do pi r square. But if it is a square or rectangular cross section given here. What is given as length and breadth? What is the area shown here? It is L into B. But usually in 10th standard, the numericals come like a cylindrical wire where we have to use A as pi r square because this is a circular area. So we know the equation R is equal to rho into L by A. Now it's time to find out what is the unit of this rho. So finding out the unit for rho, we have to create an equation for rho. What is rho here? A is multiplied to R and L is taken to the denominator. So we will get rho is equal to RA by L. So rho is equal to RA by L. Children, now we are going to take the unit. So what is the unit for resistance? You know, it is ohm. So now we are going to write the unit of resistivity or specific resistance. So what is the unit of R? It is ohm. What is the unit of area? If the standard unit is meter square. What is the unit of length? It is meter. So we cut 1 meter here. So hence the unit of resistivity is given as ohm meter. So the unit of resistivity is ohm meter. But when we write this equation like this, there can be a question asked to you. What are the factors on which resistivity of a conductor depends on? So sometimes while looking at this equation, you may write that it depends upon resistance, it depends upon area, it depends upon length like that. But it is not true, children. Even though we write this mathematical equation, you know that this R again contains L by A. R is the ratio of L by A, so that it totally get cancelled, and the resistivity of a material is independent of the dimensions of the wire. You may please note the point. The resistivity of a material is independent of the dimensions of the wire. What do you mean by the dimensions of the wire? It means that it does not depend upon the length of the wire, it does not depend upon the area of cross section like that. So somebody may ask a question to you. When we stretch a wire, what happens to its resistance? Of course the resistance changes. When we stretch a wire, the area decreases, the length increases. We will come to it later. But when we stretch a wire, somebody asks you a question, what happens to the resistivity? You should say that there is no change for resistivity, because resistivity is independent of the dimensions of the wire. So you may think that on what factors does this resistivity actually depends on? So we are going to discuss those 2 points. The resistivity of a wire depends on the nature of the material and temperature only. So the resistivity rho depends on only 2 factors. What are they? It depends upon the nature of the material. It is different from a alloy, it is different from a semiconductor, it is different from an insulator, like that. So rho depends upon the nature of the material and rho depends upon temperature. So once again you have to note the point. Resistivity of a wire is independent of its length or area. When the wire is stretched or wire is compressed, nothing happens to resistivity. But if the nature of the material changes, like that from metals, semiconductors, insulators, the resistivity depends upon the nature of the material. The resistivity depends upon temperature. Now we are going to define what is resistivity. So we have already got the equation. Rho is equal to RA by L. So in this, put area of cross section is equal to 1 meter square and length is 1 meter of the wire. So we put A and L as 1. What will you get? The resistivity rho is equal to R. So how will you define resistivity? Resistivity is the resistance of a wire when the area of cross section is 1 meter square and length is 1 meter. Once again, to repeat, what is it? The resistivity of a material is the resistance of a wire of unit area of cross section and unit length. In your NCERT textbook, there is a chart given to you, that is the resistivity of various materials are given to you. That is, silver is given to you, mercury, alloys, etc. are given to you. So I may write some examples for it. So silver. What is the resistivity of silver? It is written as 1.6 into 10 raised to minus 8 ohm meter. So next to resistivity of alloys. So silver is a metal, we know. So I have taken the representation of silver for alloys. Alloys, that is, we can take the alloy as nichrome, where the resistivity is 100 into 10 raised to minus 8. 100 into 10 raised to minus 8 ohm meter. Just compare it. Which is having more resistivity? The figure itself make you understand that nichrome is having high resistance. So we are coming to the point why this nichrome is used in heating devices. Why can't we use a metal, silver or a copper, which is a good conductor of electricity, cannot be used in heating devices. And there are another category of materials called semiconductors. Usually we know about solar cells, we know about electronic devices where we use semiconductors, where this silicon, I'm going to write silicon, for which the resistivity is only 640 ohm meter. 640 ohm meter. Simply 640 ohm meter is given for insulators like ebonite. Next category is insulator. These are all given in your textbook. You can refer to it. Insulator, it is an ebonite which is an insulator. Its resistivity lies between 10 raised to 15 to 10 raised to 17. By giving this data, a question can be asked. Which can conduct more? So of course we know that a metal can conduct more. Here the resistivity is of the higher order. Here the resistivity is of the smaller order. Among this material, which conducts more? Those material having less resistivity will conduct more. That's all for today. See you the next day. Thank you.